Gauss's law tells us that the electric flux is equal to the amount of charge divided by epsilon naught. So if we know the amount of charge we have, we know exactly how much flux there is. And there's actually another way we can represent it using the flux definition through this integral. Again, think back to a point charge with a bunch of imaginary surfaces around it. If we draw a surface that surrounds the charge, we have a net Q, which means we have a net flux. If we don't surround the charge, we end up with 0 for Q and 0 for flux. For Gauss's law, you're either going to be looking at how much charge you have or solving for the electric field here. Now, these are really the only two options we have. In order to make this integral very simple, we actually have a couple very specific scenarios for surfaces that we'll actually use. Let's say we're working with a spherical charge, so imagine this in 3 dimensions. We can know that the bigger surface around that charge is just a bigger sphere, with surface area 4 pi r squared. So if we know the integral dA, and we know that the ER is kq over r squared according to Coulomb's law, we can actually quantify exactly how much charge there is. Another case is where we have a really long charged wire, and in this case we'll do an imaginary cylinder around it. In this way, we'll make ER, the electric field in the radial direction, always perpendicular, eliminating this cosine theta. So the area is just the area through which the flux goes, which is just this kind of cylindrical part of our surface, as 2 pi r, the circumference, times its length, and the flux will just be equal to E times that area. And if we have those two pieces of information, we can get the charge on that line right there. A final example is where we have a plane of charge, and in this case, we'll use an imaginary cylinder oriented in a different direction. Here, we can say that the electric field lines are going to point in the z direction through the tops and bottom. So the area we're looking at has 2 pi r squared, and the flux will just be E times whatever that area is. Think about all these different dimensions and the definition of flux, and it really just comes down to, can you solve for E or can you solve for Q?